Well, the people have spoken, and it is loud and clear. I've heard requests for adding, requests for subtracting, and even some fringe requests for multiplying polynomials. Today is the day we will do all three. The first thing we're going to start out with is how we can add polynomials, and there's basically two methods that we can think about doing this. So with all of our polynomials, basically all we're saying is it's some equation thing, right? There's some x's, maybe we have some other variables, y's, and everything mixed in there, but we're just starting out with single variable. So for my polynomial function, I'm going to start out with this first one here, which is this, that I want to add 3x cubed plus 2x squared minus x minus 7 with a single x cubed minus 10x squared plus 8. So if I'm trying to add these two things together, there's one way I can orient it, and I'm going to orient it vertically. So the first one I'm starting out here, I'm starting out basically as bucketing these things in their own unique columns. So there's my kind of like red column there. I have my orange column here, just trying to keep my sign straight. I don't want to start writing over what I've got here. I've got kind of a green column here. And then let's end with a nice blue column as well. So when we are doing this thing, we want to think about, okay, well, what if I was like adding, let's say I wanted to add like 123 to 242, okay? If I were adding these things together, what would I set it up as? I would set it up with my ones, like this, my tens in this column, and my hundreds. The little s's I'm writing here really are not working out too well. But basically, that each of these columns represents a degree of 10, right? So this is my ones place, my tens place, my hundreds place. Now we have the same thing true here, except for we're talking about degree. So this is like saying I have x to the 0, and I have some number of those things. Oops, let's keep it in the same color here. Oh man, my fat finger on the right click. Let's see, third time's the charm. I'm giving up, moving on. Okay, so the next bucket here we would say is my x to the first bucket, and then I've got my x to the second bucket. Maybe, maybe not, I continue, or maybe I don't have a value in a certain bucket, but now here's my x to the third bucket. Threes, again, nearly impossible. Nobody can draw 3. I'm stating it right here. Oh, there we go. So as I look at these things, the things with the, I really need a 0 there. Can't live with that not being 0. There we go. Fifth time's the charm. When I'm looking at these are my constants. -7 plus 8 is going to give me 1. So that's where this 1 is coming from. Now I look at my x's. Now I had a negative x here, and then I did not have any other x values, so it's just going to remain negative x. The next one I'm looking at here is my 2x squared with a negative 10x squared. So this is going to be negative 8x squared when I add these things up. And then last but not least here, I have a 3x cubed and an x cubed. So this is like 3 plus 1, which is 4x cubed. So my final answer here would be the 4x cubed minus 8x squared minus x plus 1. Now we can also do this horizontally. So when I'm looking at these, I want to keep my underlining colors the same. So I'm going to say red is going to go with any other cubes, which I don't have any other cubes. I'm going to use orange for my quadratic, excuse me, for my second degree, and I don't have any here, but I do have one here. I'm going to use green for my x's, so I got 2x here, a negative 2x, and I have a positive 12x here. And then last but not least, I'll talk about my constants in blue. So my naming for these things remain the same. So this is like my x to the third stuff. Oh my goodness. Whatever. We know this is a 3. If I could just draw one, there we go. Here again, all of my x to the first things. We said blue was my x to the 0 stuff. We see that I don't have any x squareds here, and that's totally fine. And then we'll do the same over here now. I didn't have any x cubes. And let's see if I can draw the 3. There we go. And I've got an x squared. I actually got 5 of them. I've got my x to the first, which we would just say are x's, and our x to the 0, which we would just say are our constants. So again, adding these things up, all of my x cubes add together, that's this chunk here. I have all of my x squareds together, which is this chunk here. I get all of my x's together, which is now these two terms. So these are going to combine to give me my 10x here. And then I've got my constants as well, which is the 1 and the -4, which add up to give me the -3. So hopefully this is fairly straightforward. Basically, it's the same things with the same things, right? If these were apples, these are oranges, these were grapes, and these are blueberries, I just have a certain number of them, and I'm adding or subtracting within that group. I can't say I've got 2 apples is equal to like 7 oranges or something crazy like that. So now we look at doing some subtraction for these things. It is exactly the same. We can do this either vertically or we can do this horizontally. When I'm doing this, I want to set it up as if I had a column. So I've got column for my x cubes. I've got a column for my x squareds. A column for my x's, which is x to the first. And then a column for my constants, which is x to the 0. When I do these problems, which I strongly recommend to you guys, is that we distribute this negative sign and switch to doing addition. So what that means is I have subtract this whole thing here. So what that's really saying is I'm adding -2x squared. I'm adding a -6x squared, which I think I said squared, but I meant cubed here, 2x cubed. I'm subtracting a negative, so here it becomes plus x, and subtracting 1 here. So that's how we get these right here, and now we're just adding them up. So most people find that generally to be easier. Oops. Get our blue over here. Green's right here. Orange and red. So again, as we're doing these things, I recommend that you do your distribution and then you just switch it to addition here, but you don't have to. If you like doing 8 minus 2 and you want to put the 6x cubed, that's totally fine. It is our ultimate answer, so it doesn't matter one way or the other. Likewise, if I have horizontal subtraction here, I would recommend the same thing where we're going to distribute this to all of our terms. So again, I strongly recommend we take our negative sign and distribute to all of these things, but you do you. It's still totally possible to just pair them up and do it individually, still setting it up horizontally. I would refer to my x cubed values in red, which I don't have any on this problem. My x squared values here are going to be orange and orange. And here I see it's a little bit easier to add these things up, so I just end up getting my -x squared here. My x's are in green. Do my distribution. And I'm going to add these things up, so I just get 2x. And then last but not least, I've got a constant here, but I'm subtracting the -4, so really this is addition, and that's where my +4 comes from. So now let's get into the thing which is a little bit more difficult, which is multiplying polynomials vertically. So we've covered addition and subtraction, now we're on to multiplication. As we look at multiplying two polynomials, I'm going to do this in 2 steps, okay? The first step, and this one, the reason I'm doing it in 2 steps is because this is a binomial, but if this is a trinomial, then I do it in 3 steps. So basically you take one of these things, and then you take the other, and you're going to multiply piece by piece and start adding those things up. So I'm going to start with my -3 here. So this -3 is going to multiply by the 4, the 2x, and the the -x squared. So when I am doing that multiplication, -3 times 4 gives me -12. -3 times 2x gives me -6x, and -3 times a -x squared will give me a +3x squared. The negatives cancel off. So that's what I'm getting for the first one. Now for the second step, I'm going to go through and do x times each of these things. So I'm going to do x times the 4, so this would be 4x. I'm going to get x times 2x, which would be 2x squared. And then I'm going to do x times my -x squared, which would be -x cubed. So now I have these things written in such a way that I can take the columns and I'm going to add my columns together. So just like the one we did previously, once we've done our multiplication step, we're just going to add our like terms. So here I've got my constants carry down to just give me my negative 12. I had negative 6x, positive 4x will give me a negative 2x. I had 3x squared, 2x squared, which is going to be 5x squared. And then again, I just have my negative x cubed sitting on the outside. So my final answer for this problem would look like this. If I want to do this thing horizontally, I can totally do that as well. The thing is, I'm going to start by doing the x to each of these terms. So I'm going to say x to this, x to that, and x to this one. So here, if I did x times this thing, it will give me, so I'm going to do it a little bit differently than they do. So they do this whole chunk to each of these individually. I'm going to do one at a time. So if you want to follow along with this, that's fine. If you want to follow the way that I write it out, perfectly fine as well. So now I'm saying I got x times, and here's my 3x squared. And now I'm just going to say, okay, plus my next thing. And the next thing can be negative, and that's totally fine. I'll deal with that afterwards. So negative, oops, I'll keep my x's out in front. So x times my negative 2x plus, and now here's my x times my negative 4. Now I'm just going to evaluate for each of these things. So this is 3x cubed, this is minus 2x squared, and this is minus 4x. Now I'm going to do the same thing, but I'm going to do it for my negative 3. So negative 3 is going to go to each one of these things. And so I'm going to set this up as negative 3 times 3x squared, and I've got plus, and here I've got negative 3 times, here's my negative 2x, plus, now I've got negative 3, and here's times my negative 4. So the reason I'm just writing this below is I've just run out of space horizontally. So I'm going to simplify this. So this is negative 9x squared plus 6x plus 12. The negative and the negative cancel off here. So now I'm going to add these two things together for my final answer. So now I start seeing, okay, well here I have an x cubed and I have no other x cubes. So my final answer here is just going to have 3x cubed. Now my next is I'm looking for x squared. So here I have negative 2x squared and here I have negative 9x squared. So these two together, I guess I'll use another color here just to represent each one of these things. So here's my negative 2x squared, negative 9x squared, and that's going to give me negative 11x squared. Next one we'll do in purple here, which is I have a negative 4x and I have a positive 6x. So that's going to give me a positive 2x. And then I've just got this plus 12 at the end for my constant. So I'll just stick with green here and we'll say plus 12. So this is what I would be looking for my final answer here. And this is kind of setting it up more horizontally to do the multiplication out. Again, if you wanted to do it as like this whole red chunk by each of the blue chunks, totally fine doing it that way as well. So again, just two different representations of doing the same thing, and that's doing it horizontally. Now we get to the really kind of new or tricky element of this, which is that if I want to multiply three binomials, how do I do it? So if I want to multiply three binomials, the first thing I have to look at is just do two of them first, okay? So if I want to multiply three chunks, just take these two chunks and multiply it out. If I multiply these two chunks together, I have to FOIL this thing out. So FOIL says we do our first, which will give me an x squared, which is the x and the x. My outside, which is x and positive 4, so that'll give me plus 4x. My inside, which is negative x. And then my last, which will give me negative 4. Oops, there we go. So as I'm adding these things up, it just looks like x squared plus 3x minus 4. And that we see right here. Now once I've got that done, I'm going to do the exact same thing that I just did. So I won't write out every step here just because my handwriting is pretty terrible, but this is going to get distributed to each of these terms. Oops, try and represent it like that. And then after I do that, I'm going to get this distributed to each of these terms. And again, if you want to do it slightly differently, like you want to do the x plus 3 to the x squared, the x plus 3 to the 3x, and the x plus 3 to the negative 4, you are more than welcome to do that as well. Doesn't really matter one way or the other. And if you want to set it up as separating into the two chunks like it has written here, you are more than welcome to do that. There's a lot of different ways of arriving at the same answer here. It's just a matter of like, what is your personal preference in organizing these things? So now that we're looking at this, we're saying, okay, do all of our distribution. So this first chunk here turns into this. Our second chunk here turns into that. And then we're just adding these things together. And so here we get our final answer. So again, the big thing that's different is you just want to do two of these binomials first, and then once you have that, multiply it by a third. Now you may be saying, okay, well, those really weren't the ones that I wanted to multiply together first. When the problem was like this, x minus 1 times x plus 4 times, we get x plus 3. I really wanted to multiply these two first. Well, go for it. Follow your heart, right? If you multiply these two first, we would get x squared plus 7x plus 12. And then I would just be multiplying that thing by x minus 1. Spoiler alert, we get the same answer in the end. So it doesn't matter which route you go to get there, we're still going to end up in the same place. So now let's take a peek at a few special product patterns. So again, if you identify these things, that is great. It will save you a lot of time. But like ultimately at the end of the day, if there's only so much space in your head and you're like, you know, I got to dump something, you don't need to memorize these things, because we should be able to kind of just brute force our way through it without like identifying them. But they are very helpful. So when we're doing this, we have our sum and difference product. So this looks to me exactly like the thing we were doing before, where if I gave it to you like this, we would factor it into this thing. So this is just the flip of the coin here. So all these top three we've already seen before. The cube of a binomial is something new, and I'll talk about that in a second. So sum and difference is just saying, okay, what's happening? The a and the a gives me a squared. The b and the negative b gives me negative b squared. But the outside and inside cancel each other off. Here I get positive ab in the middle and a negative ab on the outside, so those two will cancel each other off. And here's another example of that. For our square of a binomial, again, we are way past the stage of saying x plus 3 squared is equal to x squared plus 3 squared, right? This is not a thing. It's never been a thing. It's never going to be a thing. Okay, this is not what we are doing, right? We're taking this thing and it is our distributive property on two binomials. So we have to actually FOIL this thing out so it would look like this. And if you're thinking, well, how do I do it so quickly? How do I know what this middle term will be? It's just going to be 2 times this first term times the second term. That's it. And the same is true when I'm doing subtraction. It's just that it'll be negative. So here's 2ab and here's negative 2ab. Again, just depending if it's a positive or negative sign. Here's an example here, pretty straightforward, using y plus 4. And here's a slightly messier version using 3t squared and negative 2. So 3t squared times 3t squared gives me 9t to the fourth. If I have 2 times 2, it gives me 4. Again, the negatives cancel off. And then I've got 2 times this times this. Well, this times this gives me 6t squared times 2 is negative 12t squared. Again, it remains negative because that's negative. So as we're doing these things, great to identify it. Awesome little time saver for us, but ultimately we don't need to memorize these things. Now let's get into a very brief sort of tangent on Pascal's triangle. Maybe this is something you've seen before, maybe not. I am drawing out the first few values here, and we will see how they come into play, and I'll explain to you how I get these values as well. The first one starts out with 1, and 1s are always on the outside. This first one here represents for a 0 degree. Okay, so 0 degree goes right here. Now what that means is this is like saying x to the 0, plus whatever, constant, whatever we have raised to the 0, right? So basically anything raised to the 0 is going to be 1. So if I have whatever it is, like say I had, x plus 2 raised to the 0, it's still just going to be 1. Okay, cool. So as I look at it, assuming my x value is not -2, because we don't want to do 0 raised to a 0. So that's my 0 degree things. It just stays my constant, 1 there. Okay, cool. So now let's talk about, here's if I had a binomial and I had the binomial raised to the first. Now these represent a and b values as I'm going through and evaluating. So if I had something like this, for example, this is my first degree. And as I look at this thing, it would be like saying x plus 2 raised to the first, which is x plus 2. Now that seems kind of silly and simple, but the important thing is that my a value here is x and my b value here is 2. And what this turns into is 1a plus the 1b. Sorry, those are kind of less than ideal equal signs there. So now it starts getting interesting when I start cubing and etc., etc. So let's do a quadratic, so we'll square the thing first. So now we're looking at this one here. So this is my second degree. With my second degree thing, I'm going to show you what it looks like. So second degree looks like a plus 2ab plus b, and now I'm going to tell you about the degrees. Okay, so the degree here counts down depending on the degree here. So this is a second degree, now it's first, and now this b is counting up as first, and my b is second here. If this is a little bit above your head as of right now, that's okay. We'll talk about it a little bit more later on, but this is what's kind of behind the cubing binomial stuff. So as I write this out, if I wanted to write b to the 0 here, I could, and if I wanted to write a to the 0 here, I could. Now, why is this important? Well, let's look at the one we just did before, right? What if I said I have y plus 4, and I want to square that thing? What this turns into is my pattern of a, which is my y, so a, which is my y value, and b, which is my 4. This turns into y squared plus 2. Here I have my a value, which is y, my b value, which is 4, and I'm going to say plus my b value, which is 4, squared. So what does this simplify to? It simplifies to being y squared plus 8y plus 16. Oh my goodness. It's the same thing that we got up here when we did it. So we can use Pascal's triangle to start developing what these things will be. And now I don't have enough space to write this one out, nor I think it's super advantageous for you, because I feel like I'm starting to lose people here, even though I don't have a live studio audience here. Corona safety first. But when I look at this one here, what are my leading coefficients here? The leading coefficients that go in front of these things, right? These values right here are going to be 1, 3, 3, 1. So let's look at this one here. So the last one we're going to look at is the one we're going to be doing as an a value. Let's write the thing out first. So let's write p minus 2, and we want to cube this thing. So again, cubed is going to use this one right here. So this is my third degree. So looking at my third degree thing, I'm saying, okay, well, the a value here is p, and the b value here is -2. And it's important that we keep the negative with it. And so when I'm doing this, I'm going to write this whole thing out just in terms of my Pascal triangle information. I'm going to say I get 1a to the third, b to the 0. I'm just going to be super explicit in all of these things here. Now I get 3, a to the second, b to the first, plus, now again I've got a 3 again here, 3 to the first, a to the first, b to the second, and then I get plus 1, a to the 0, b to the third. So how I'm getting these values is I take the 2 above it and I add them up kind of like an arrow like that. So 1 and 1 gives me 2. 1 and 2 gives me 3. 1 and 2 gives me 3. The next one below here, I'd have 1, 4, 6, 4, 1. So as we go to like 4th degree, yada, 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 as we continue on. So just so you know, like that's what this pattern is. The 1, the 3, the 3, and the 1. And if you wanted to do this actual like distribution work out, you're more than welcome to. But I'm just telling you that's what it's always going to be. So either use the special factoring, or excuse me, the special product pattern, or not. Doesn't really matter. You can still brute force your way through it. But let's write this out and just finish up with this example. So looking at this one here, 1 is just going to be 1, so cool. A value is p, so here I just get p to the third. And now my b value is going to be raised to 0, so that's just going to be 1. So this just ends up being p cubed. Okay. So p cubed plus, now I get 3 times my p value squared times, now my b value here is negative 2. Plus, now here I've got a 3 for my constant, p to the first, and now here I've got negative 2 squared. And then last but not least, I have plus 1, so I'm not going to write the 1. A value to the 0 is 1 again, and then b value here I got negative 2 to the, whoops, negative 2 to the third. So let's scroll down just a smidge more here and finish out this problem. Simplifying this thing here, p cubed doesn't have any other p cubes, it's just p cubed. Cool. Well, here I have negative 2 times 3, which would give me negative 6p squared. Now here I have my negative squared, which is going to be a positive. So here I get 4 times 3 is 12, so here I get 12p. And now here I got negative 2, negative 2, negative 2, so it's going to come out to be negative 8. And we see that this thing here matches up with the thing over here. So that's how Pascal's triangle works in terms of getting the factors that are going to sit in front of these things. The A thing is going to count down in descending order for the variable, or excuse me, for the exponent. So here I had a to the third, then I get a to the second, then I get a to the first, then I get a to the 0. B counts up in ascending order, starts at 0, goes to 1, then to 2, then to 3. So again, if this is a little bit crazy complex, you can check out more. It's Pascal's triangle, so let's write that. So if you want to check out more, that's Pascal's triangle, and you can look it up. Pretty interesting. Also works for combinations of things as well, which you might get to once you start seeing like some statistics work. So let's actually look at a few examples here. So here we're going to use our special product patterns to see if we can kind of quickly and easily figure these things out. So as I'm looking at this, I'm looking at, okay, well, I've got a value minus a value, and then I've got the value plus the other value. So this to me looks like my sum and difference. So this one looks like I'm just going to have this thing squared minus this thing squared. Now just keep in mind that the 4n is the like quote unquote a thing. So that whole 4n is being squared. So if this is my a, I should write it like this, and I'm squaring it, so I'll end up getting 16n squared. And then for my b value here, I would get 5, and so here I've got minus 25. The next one here looks like a square of a binomial. Looks like I've got something minus something, and I'm just squaring the whole chunk. So if I'm going to square the whole chunk, I end up getting my second degree for my Pascal's triangle. So my coefficients here are going to be 1, 2, and then 1. So as I'm looking at this, the reason it's got negative 2 is it's carrying the value, it knows it's a subtraction. So instead of using it there, it's including it here, but you can do either way, it'll come out the same answer. So here, if I had my a value as 9y, I'm saying, okay, well, that thing is being squared here. So my a value is being squared. So this is being squared right here. And then I would have my a value to the first, and then I would have my a value to the 0, which is why I don't see it here. Then I do the same thing for my b value. So here's my b value, and my b value is negative x squared. So here it's raised to the 0, so it's just 1. Now here I have negative, and then here's my x squared. So this is going to take the negative value and square it. So this one ends up becoming positive here. And so now when we're doing this thing, again, as I look at the leading coefficients, this would just take it as if it were an addition sign. So I'd have to change this to being like this. So if I want to write this as like a, whoops, I guess I should do my a in red. And I'd say plus, and that's where I put this thing as negative x squared. So again, that's where the negative is coming from in front of the 2. They just don't have it inside here. So sorry if that's a little bit confusing, but again, just trying to connect this back to Pascal's triangle here. So hopefully we have a little bit of a deeper understanding of like where that thing's coming from. Here it was to the 0 degree, so it doesn't show up. Here it's to the 1st degree, that's why it's negative. And then here we have it raised to a 2nd degree, and that's where we're canceling off our negative. So that's where we're seeing, again, our b value coming into play here, but now we're squaring it. So now this thing is positive again. And we see that our answer comes out to be this. So exactly like we saw before, just with some different values for a and b. Last one here, we're using a value binomial and we're cubing it. So this is a cube of a binomial. If we're really good at this and we identify our pattern here, we should see a 1 out in front here. We should see a 3 out in front, a 3 out in front, and then we have, again, a 1 out in front here. This is just multiplication. I don't want to make you think it looks like 12 or something like that. And then from here, I'm taking, okay, well, what is my a? The a here is ab. So here's this thing to the, whoops, this thing to the 3rd, this thing to the 2nd, this thing to the 1st, and then it's to the 0. Okay, cool. Then I see this, and my 2 is going to go in ascending order. So here it's to the 0, now here it's to the 1, here it's to the 2nd, and here it's to the 3rd. And now we add all these values up, we do our multiplication, and this is where we arrive at. So those are our special product patterns. Again, we started out with adding and subtracting these things. Basically, they need to have the same sort of base. So again, think about if I have x to the 3rd, I don't know what that x value is, so I can only add it with other or subtract it with other x to the 3rd things. Likewise for x squared, x, and then my constants. Subtracting, again, just don't forget to distribute your negative sign. When we're multiplying these things, we can multiply vertically, kind of in chunks like we've done before with just like, tens or hundreds values. And we can also do this thing horizontally by kind of pairing off chunks. This is one way of doing it. Here's another way of doing it. And we can also multiply our binomials if we've got 3 or more. So here we would just do 2 at a time, and then we would multiply that just like the one above. We have a few special product patterns here for multiplying things, which come in really handy. But again, ultimately, if we only have so much room in our brains and we need to push something out, we could brute force our way through this. We have Pascal's triangle here, which looks like a string of 1s on the outside, and then the 2 above add to the 1 in the middle. Here's 0 degree, 1st degree, 2nd degree, 3rd degree, 4th degree, yada, yada, yada. So this just gives me my leading coefficient for each of these as they ascend for my b's and descend for my a's in terms of the variable's exponent. We did an example right here. For our sum and difference, our square of a binomial, and then a cube of a binomial as well. Hopefully this was everything you wished and more. Don't forget to like, subscribe, donate money, just send it in a brown paper bag to the school, and they'll just organize it for me. So perfect. Hopefully you guys are good to go on 6.3. I will see you for 6.4. Even more exciting.